force, that is contact force. Now, from the term itself, contact forces, that means when two objects are getting in contact with each other, a force is being generated, which is called as contact force. It is simply the direct contact of the bodies, where direct contact comes. For example, if you are walking on any ground or any floor, that means you are contacting that floor. There is a contact between you and a floor. That force which has been developed there is simply called as contact force. Fine. Now that force can be definitely due to pull, or it can be due to push as well. Fine. As in the picture itself, you can see here that there is a force between those two objects. For example, if you have a weight of 50 kg, there will be a reactive force of 50 kg from the floor as well. Right? There will be a reactive force, and that force that is between two objects is called as contact force. Secondly is body force. Body force, again, from the name itself, you can get an idea what does the body force mean. The body force is basically here you do not need to get in contact with anything. It is within the body, right? You have a body, any type of body, and the force that is in between the particles, in between the particles together to hold them together. Simply, to hold different particles together, there is a force inside which is called as body force. And these forces basically are responsible for holding or forming the rigid bodies. If we do not have those body forces, what will happen? The particles will get scattered, right? You won't be able to have a rigid body. Okay. Thirdly, point force. Point force means that you have a force which is restricted to a single point only. That means force has been uh, put it on in such a way so that it is not scattered. It is restricted to a single point. For example, you have a picture here, you have a element, let's say it is a beam, and there is a force on only one point. Therefore, here you can simply say that it is a point force. It actually acts on very small surface of area compared to the total surface area of that member. Nail is being pulled out of the wooden log, like, and the force is being applied. Definitely, you need to draw force when you are putting the nail into the wood, right? And the same amount of force has to be applied in order to take the nail out of that wooden timber log. Fine. This is point force. Then we have distributed force. Distributed force again means that the force has been distributed to a larger area. Simple. It has been distributed to the larger area, and that is called as distributed force. And in our structure analysis, we usually are concerned with the point loads and the distributed loads. Now, there will be different types of distributed loads. Either it will be uniformly distributed loads, or it can be uniformly varying loads. There are a number of loads about which we have to study in due course of time. Maybe those types of loads are in your engineering mechanics only, or they are in your structure analysis one, where we will thoroughly study the types of loads that we have to come across. Here in this chapter, you will get an idea what actually these types of forces or loads are. Distributed loads, again, you have picture, right? The load is being distributed in both the pictures evenly on a larger surface of the area. And then we have external and internal force. What does that mean? External, definitely, it is something associated with the outer force, and internal, it is associated with inner force. Like you have a picture here, For example, if a load is being applied to any member, let's say this is a structural any member, and the load has been applied on it, an external load or force, which is also called as a load, external force, or simply we can say a load is being applied. Then what will happen? That member on which the load is being applied, it will certainly offer what? It will offer some resistance or reactive force, right? The amount of load that has been applied externally will give what? It will give a reaction, and reaction will be what? It will be same in magnitude as that of the external force. If you have a 10 kilonewton load externally applied on any beam, there will be a reactive force of 10 kilonewton on the same point, on the same point. And that resistance which has been offered basically to retain its shape. Otherwise, if we apply a load which is more than what the member can resist, what will happen? There will be a deformation, right? It will displace, there it will get displaced. And just in order to keep it in equilibrium, what it has to do, it has to offer the same amount of resistance, or that resistance is called as stress or internal force, which is called as simply internal force. External force is equal to internal force. Okay, we'll move ahead. And then action and reaction. Simple. You have been reading this from a long time now, I guess in 10, 11, 12. Action is equal to reaction. The amount of load you give, the amount of reaction you will get. Simply. As in the if there is an air in the balloon, what happens? The air gets if you have removed the hindrance of or if you have removed the what we call as the tie of that balloon in order to get it emptied, what happens? The air gets rushed down, and at the same time you could see the balloon is going up. That means reaction. What reaction? What has reacted here? The air has escaped, and it has escaped in the direction which is downwards. And at the same time, that downward force has what has it done? It has given a reactive force, and that reactive force has made the balloon to go up. Simple. And as per the Newton's third law, also, we say that if a body is being exerted with a force, right, some force has been applied on a body, that will do what? It will exert similar force on the former body. It will exert similar force on the former body. In second picture also, you could see that action is always equal to reaction. The amount of action that has been given to this board has given the equal amount of reaction. Okay. Another type of force is frictional force. Now, what does this frictional force mean? Frictional force is simply what? It is actually the resistance which is being uh, provided when two bodies get in contact with each other, right? It is the resistance simply when two bodies get in contact with each other, or the surfaces get in contact with each other. For example, here you have a picture wherein you can see there are two guys, guy A and B. One is on his skates on snow, and another is with on simple grass. And he also wants to get skidded or slided. He wants to enjoy slides. But at the same time, you can yourself evaluate that the guy A, the person A, will be offered lesser amount of resistance, right? The lesser amount of frictional force will be applied because there is very less friction between what? Between snow and his skates, right? There is quite less. But on the contrary, the guy B who is trying to get slides on a simple road or simple grass, the friction forces will be more, right? Here the frictional forces force guy B will be more as compared to guy A will be less. That is why if you have less frictional force, you will get you are bound or you tend to move forward
Excuse me,
very
sir.
quickly. Yes. Yes. Tell me.
Excuse me, sir.
Yes.
There are some. Uh, so there are some students that want to join, but the previous password is showing password incorrect. Maybe the password changed when you disconnected or something.
No, I didn't disconnect. It is the same class going on. I don't know why. Let me check it one more time. They have not been joined. Is it Fiza and Hadika Shafi?
Yes, it's Hadika. Hadika.
They
Yes,
are
Hadika.
being allowed now. They were in the room only. Okay.
Okay, thank you, sir.
Okay, that's okay. Okay. And now, with regard to the picture, please mute your mics. Okay, with regard to the other picture, what is it showing? That if we are applying a force, a pushing force, it's not a pulling force, it is simply a pushing force. And what happens here? If you have a block or any member which is on the simple ground and you are tending to move it by applying some force, what will happen? It will attain some motion, right? But it will also depend upon what the friction that is being provided between the road or the contact surface. Now if you will see, if you have a larger area, bottom area, then in that case what will happen? There will be more pushing force that is to be applied. Therefore you can easily say it actually depends upon the two contact surfaces, and on that basis the pushing force, the magnitude of pushing force is to be evaluated, right? So this was regarding what? Frictional forces. And wind forces, again, I hope you know what are wind forces. The forces which simply gets exerted due to wind on any object are called as wind forces. And now we'll try to understand what is cohesion and what is adhesion, right? Now, from the picture itself, also, I hope you might have got an idea. Frictional force. What is frictional force? Sorry, what is cohesion? Cohesion basically occurs between the material having this. Having the same particles or having the same molecules. Right? If we have a material which has the same molecule particles, then in that case, they get bounded together by cohesion, right? For example, if we have soil particles, they get and they get in contact with each other, and they are associated with each other because having the same particles, and the force that has been developed between the same particles is called as simple cohesion. And whereas addition is from the term itself, addition, right? It is simply the force that is being developed between the molecules of different materials, between the molecules of different materials. If for example, if we have two different materials, and we want to join them or associate them in such a way so that they won't get uh, separated, right? What we do, we use adhesive forces, we use adhesion agents, right? By that adhesion agents, what happens? Two different types of molecules or two different types of material gets attached to each other. Fine. From the first picture itself, you can also see the same molecules of any material when there is a force of attraction between them, force of attraction, right? They are associated together. They are plugged together. Then that is called as cohesion. And if we have particles or molecules of different of different material, then that is called as addition. Or same the second picture, in second picture you can also see The inner portion, that is this portion, it is made up of same molecules, right? And the force or the force of attraction that is there within the same molecules of the material, then that is called as cohesion, right? And at the upper and the bottom end there is some another material with which these similar molecule type material has to get associated, then in such case it is called as adhesion. Okay, I hope you understand what is the difference between the cohesion and adhesion. Okay, we'll move ahead. And hydrostatic pressure. Simple, hydrostatic means from the term itself, it is the force which has been exerted by water on any body when it is being obstructed by anybody. For example, while constructing the dams and not only dams, all other water resources which we have around, there we calculate hydrostatic pressure, hydrostatic force, which can get exerted on any structural member. And such forces are by which get exerted by the water are called as hydrostatic forces. Okay, this was regarding the simple terms that we use in with regard to the forces that gets applied on structures. I guess our time is over. We will do one thing. I'll reconnect you. I'll reconnect you again because our 40 minutes or 45 minutes is about to complete. It is just 4 minutes. We'll start a new meeting now. I guess it will take us more 10. Is my voice quality audible to you?
Yes, sir.
चले ठीक है. Will
Sir, am I not audible?
give. Sorry,
Am I not audible?
you. It's. I'm not able to hear you. It's quite low. Your voice is quite low. I do. I guess just do some
Maybe
settings with
network
your
issue.
phone.
Okay, sir.
Okay, I will start it now. 10 more minutes. Okay, we'll be now discussing. Now we got to know that there are many types of forces that can come on anybody, right? Meanwhile, somebody had asked that can we say the simple this frictional force as contact force? Yes, definitely. It is also a contact force. Only difference is there in the first force where we just mentioned contact force. There it was the simple single contact, right? In that surface contact, it was the single point that uh, was in contact with the another single point of the this road or whatever that is, wherein the weight of the man was being assessed. Whereas in case of friction force, it is also a surface force, but there is a constant change of the surfaces, constant change of the surfaces, and constant change of the force and the reactive force. It is all, we can also say it a contact, but we can say it a surface frictional force, not only surface force, because surface force can be a simple touch on the surface where you can calculate the external force and the internal force. Okay, fine. We'll move ahead. Now, these forces can come on any body in various directions, in various forms, right? And there can be a number of forces that can actually act on single body, and the form of that forces, the system of that forces will be discussed here in the planes. I mean, the way, the manner these forces come on the objects will be discussed here. Firstly, we have the first system of forces, which is called as coplanar force. Right? It is called as coplanar force. Second one is your concurrent forces. Fine. And the third one is collinear forces. Fourth one is coplanar concurrent forces. That means it is Yes. Any problem?
चाह रहे हैं पर आप उनको तभी आपने उनको ये उनकी ज्वाइन रिक्वेस्ट शायद एक्सेप्ट नहीं की है तो ज्वाइन करना चाह रहे हैं
अच्छा. Okay, I guess all of you have joined now. So we were discussing here about the various system of the forces or the forms of forces on any system, wherein the first type of force was coplanar, right? And the second one was concurrent forces. Third one is collinear forces. These are the main types of forces. That means these three are the main type of system of forces. That means it can be a co-planar, it can be concurrent, it can be collinear, and vice versa, right? And vice versa. Vice versa means the system of forces can be coplanar also, it can be concurrent also, and then it can be only coplanar and non-concurrent force, and then it can be non-coplanar and concurrent force. I mean, these are the combinations which have been derived from these three types of system of forces. And then finally it can be non-coplanar and non-concurrent forces. Fine. And these two, that is like parallel forces and unlike parallel forces and special forces, they are the another types of system of forces. Now we will try to understand what are these. But meanwhile, after these classes, consult your books as well. Don't rely only on these lectures. Consult books and clear your concepts. What are these? Because here you will have to understand what are the various different systems of forces.
हेलो
Firstly,
हेलो
it is yes. Any problem?
सर हाँ सर बुक्स कौन सी हम मतलब ये सर वो
You can go with whatever number of books, because I guess the books are mentioned there on your syllabus also. उससे आप
सर
पढ़ लो.
खुरमी कैसी है खुरमी
हाँ, वो भी ठीक है. That is also good. But उससे सारा तो नहीं निकलेगा, but you can consult that also. In addition to that, you can buy some more books, and you can also get some e-books as well. I don't know whether that will be available to you people or not. Just consult 2-3 books for the for this subject,
ओके सर
because you won't get all the things in only one book. And meanwhile, I guess Khurmi can be with Khurmi can do justice with 2 units, most probably. And then for your structure analysis, you can buy some books which you will need in future as well. I guess Hibler is a good book, and then there are a number of books for structure analysis.
हिबलर इज अ गुड बुक
Yes, that is a good book from which you can do your structure analysis. वो आपके आगे भी काम आएगी. So it's better to buy books. Don't hesitate or put your step behind while you are buying books. Keep a good number of books with you, so that you can consult a number of books while you are understanding any concept. That helps out. If in many times from one book a person is not able to understand any concept, but at the same time if you consult another book, you get it within no time. So it's better to consult 2-3 books to understand things. Okay, we'll move ahead. Firstly, coplanar. Fine. Planar means that is in one plane. Coplanar, that means here the forces forces here lie whose line of action lie on the same plane, right? Line of action lies on the same plane. For example, here most probably we are dealing with the 2D structures, 2D elements. 2D means simple, wherein you can assess the dimensions of the object in 2 directions, that is length and breadth. For example, if we are talking about 2D or coplanar, where you can only see length and breadth, But in 3D, what you see in 3D objects, you see length, breadth, and or width and thickness. Right there, you have three dimensions. You have three-dimensional properties to be evaluated, and such things we call as 3D elements. But in coplanar, it is only in one plane. That means the line of action is such that, for example, I'll try to make you things understand here. If you have a simple point, right, it is point A, or it's an object, let's say it's an object, and now you are applying a force. Now force again